Alright, we're continuing in Chapter 9 with Section 9.2, the converse of the Pythagorean theorem. And as I mentioned in the last video, when I'm working on problems like this, it says determine whether or not the triangle with the given side lengths is a right triangle. If it is not, state what type of triangle the side lengths form. So I usually like to start with that picture that we worked on in the last video. So here's my right triangle, where a squared plus b squared is going to equal c squared. We know that's true only for right triangles. Then, if I make my sides shorter, I get my obtuse triangle, so then a squared plus b squared would be less. And if I make my sides longer, I know that a squared plus b squared is going to be more. Sides are longer, a squared plus b squared will be more, making it acute. So the first thing that I like to do is identify the two shorter sides. That's going to be my A and B. So there's my 76 and my 98. So I'm going to let A be 76 and B 98. It really doesn't matter. You could flip-flop those, but we need to make sure that C is the longest side. So that'll be 120. Then I'm going to look separately at A squared plus B squared. So that's 76 squared plus 98 squared, and that turns out to be 15,380. So that's a squared plus b squared. Now I have to look at c squared. So c was 120, so that's 120 squared, which turns out to be 14,400. And now I can see that a squared plus b squared is greater than c squared. So if the sum of the squares of the legs is bigger, it's bigger. That's my top triangle here. That's my acute triangle. This means that we have an acute triangle. Alright, so when you're setting up your work, make sure it stays nice and organized. It'll keep you from making mistakes. If you need to draw this little picture somewhere on your paper so you can refer back to that, I think it's a great idea. As always, make sure you get help, and we'll see you in the next video.